Let's get started on angles. Let's go to the next slide here, right? See if we could follow the storyline here, right? Right. The main character in the story is someone called Jenny Sanchez. Try to put yourself in his shoes. All right, so before we move any further, I just want to cover some basic rules. Most of these rules are Form 1 rules, and some of them are some of the stuff you would have learned in SCA, right? But give me a few minutes just to go through some basics. The first thing I want to go through is the total angles in a triangle. Make sure you have your calculators on standby. How much of you all remember this? Like if I have any triangle in the world, it doesn't matter what kind of triangle, an isosceles triangle, an equilateral triangle. If I were to add up all three angles, how much would the total be? Send your answer on the chat. Right? Right, and you all are correct. All the angles in a triangle always add up to 180. So all the angles will total to 180 degrees. And most of you will have met that in Form 1, somewhere around there. So quick question, just a quick question, right? Make sure you have your calculators, like I said. If I have a triangle and here is 30 degrees, and here is, let's call it 95 degrees. I would like you all to calculate the missing angle quickly and send it on the chat, right? Real simple work at the beginning. Let's just straighten out, make sure everyone's on the same playing field here, right? Use your calculators if you have it, right? Because, you know, it will make class move a little bit faster. Right, so let's see the correct answer. I've seen a lot of different answers. So remember, all the angles in a triangle add up to 180. So if you add 1, 2, and 3, we're supposed to get 180. So let's add 30 and 95. 30 plus 95 is how much? Let me add up, but I have my calculator here. 95 plus 30 is 125 degrees. So to get this angle, I have to minus it from 180. So I just take the 180 and minus the 125 degrees. 180 minus 125 is 55, right? Now, some of you all put 65 by mistake. I'm just gonna go that maybe you typed it wrong on your keyboard by mistake, right? So the missing angle here is 55 degrees. This is something you're going to be seeing over and over today. If it doesn't fully stick in your head, don't worry, right? It's going to come up later again, okay? So let's do another one here now, right? Question part 2. Straight line angles. So let's talk about the angles in a straight line. If I have a straight line, the total amount of angles in a straight line is also 180 degrees. Something you would have also bounced up in SCA because that's on the SCA syllabus, right? So a straight line is 180 degrees. So if I have a straight line, let's just say I have a straight line, and I draw a line here, and I tell you this portion alone is 75 degrees. Do you all think you all can find the missing portion? Remember, a full line is 180. I gave you peace. How much again do we need to make the 180 degrees? A lot of people are sending answers. So far, no wrong answers, right? So to get the missing portion, which is this guy here, all we have to do is take 180 and minus how much? 75 degrees. And we're definitely going to get how much? Well, 105 degrees. Very, very simple stuff that you're going to be seeing over and over today. And you're going to be hearing me saying it over and over and get so fed up. It's just going to stick in your head. All right, so let's move on to the next one now. So we did one. We did a refresher on two. The angles in a circle. All right, so that's going to clear the screen here just for a little while, right? So the angles in a circle. If I have a full circle, how much is the total angle inside a full circle? Seen answers coming up, right? A full circle, the total amount of degrees is 360, also on the SCA syllabus, and one of the first things you would have done in Form 1. So let me give you a little question here. Let's say I have a funny looking angle like this. And I tell you, right, that this angle over here, right, is 170 degrees, right? How much would be the remaining angle? You notice the pink angle together with the black angle will give you how much? 360, all right? All right, so let's see what the correct answer is for this question. We said the total amount of degrees in a circle is 360. So the pink angle over here is the balance. So to find the pink angle, we take 360 and minus 170, because the pink and the black, they form what? A circle. So to get a balance, we just minus. So let's see if you guys are correct. 360 minus 170, and the answer would have been, 360 minus 170 is 190 degrees. And a lot of people got that correct, right? How much of you all remember the next one? Something called vertically opposite angles. Does that ring any bells to you guys? Right. Now, the technical name for number 4, well, it's vertically opposite angles. But in Trinidad, we usually don't call it that. We usually call it X angle. So that's our name for this guy, our local name, X angles. Because we use this, right? We use this to basically calculate angles in an X. And you all can see a kind of X shape here. How vertically opposite angles mean? You always see 4 angles here. I'll put 2 in pink. And I will put 2 in blue so you can see it better. Kind of dashed thing here. You'll notice where the X at the center of the X. Do you all agree that the pink angles are opposite each other and the blue angles are opposite each other? Can we agree on that at least? Right? Great. In vertically opposite angles, the angles are equal, right? So the little note here is opposite angles in this scenario are equal. I love this scenario because it's one of the easiest things you will ever come across in maths. What I'm basically trying to say is, if this angle is 100 degrees, without any calculation necessary, the angle opposite to it on the X is also 100 degrees. You can't ask for anything easier than that, okay? Now, right? That's all right. So that means if the blue angle was 80 degrees, the angle opposite that one would also be 80 degrees without any further calculation. Now, look at this diagram clearly. You all are seeing an X. If I were to connect all the angles, do you all see that we get a circle? All the angles in a circle are supposed to add up to how much again? 360 degrees. I want you all to add up all four angles, the two pink and the two blue, and tell me if you really, really get 360 degrees. Don't do it in your head. Type it in on the calculator and physically see that, hey, we got 360 degrees. Right? So here's what I want you all to take down. I definitely want you all to take down number 4. Draw the diagram for number 4 and make a note. The opposite angles are equal, because that one might be a little rusty in your head. When you are finished taking down number 4, let me know that you are finished. In an isosceles triangle, in case you all didn't remember, two sides are equal. They have the same length. So in my particular isosceles triangle here, you all see this stroke and you all see this stroke. Remember from primary school, it means that this line and this line have the same exact length. The two sides that have the same exact length, you call those two sides the legs. I know most of you all may not have learned that, right? But we usually say, hey, those two sides have the same length, but they have an official name. They are both called legs. The other side, which does not have the same length as the legs, well, his name is usually called the base. And as you all recall, the base angles are always equal. So if he is 45 degrees, the other red one, without any calculation, will be what? 45 degrees. Where the two legs meet, you call that the vertex angle. The blue angle, the vertex angle, he will not be equal to the red angles. Only the two red angles are the same. So let's do a few quick examples here to see if you catch on to the concept. So I have an isosceles triangle. I'm going to put a line here and a line here to prove that they are equal, to show, sorry. So if I tell you this side is 62 degrees, how much is this angle here? Well, let me see if you'll catch on. Well, what's the angle over here? Right. Remember, he is a base angle, so he is also 62 degrees. These two angles are always equal. Tell me something. We're going to get a different color. I like to use colors. It makes things easier to understand, right? This pink angle, will he be 62 degrees in an isosceles triangle? Will he be 62? The answer is no. Only two base angles are equal. So how do you find this angle? You'll remember from number 1, all the angles in a triangle add up to 180 degrees. So if you know he is 62 and you know he is 62, isn't it possible to add both of them and minus it from 180 to find the vertex angle? So quickly do that for me. Add 62 to our next 62 and minus it from 180. 62 plus 62, right? I think I see the correct answer. 62 plus 62 is 124 degrees. And to find him, we minus it from 180. And we get how much? I'm getting the answer. The majority of the class is getting 56 degrees. So this guy here is 56. I want you all to write and draw this example here. And while you all do this question, I'm going to draw a next one in this corner here. But I'm going to try to trick you. This side and this side have the same length, okay? Here's 55 degrees. How much is this angle here? This blue angle. Is this blue angle 55? No, guys, I tried to trick you. It's no. Remember, look at the legs, right? Where the two legs meet, isn't here a leg? What I did was tilt the triangle. I threw it over on its side. So here's a leg and here's a leg. Where the two legs meet is the vertex angle. That's this blue angle here. Here's the other base angle. These two will be equal. You see where the legs extend out to, right? So that means I tried to trick you. This angle is not 55. If here's 55, then over here is 55. So to find this angle, the vertex angle, we add the two of them, the 55 to a next 55, and we minus it from 180 degrees. Right? 55 plus 55 is how much? 110 degrees. To find him, we take 180 and minus 110, and I think we will get 70 degrees. You have to be very, very careful in an isosceles triangle. In a textbook, the isosceles triangle will be like this, where the two base angles are to the bottom. And you could take any shape and rotate it. You have to be prepared for those scenarios, okay? If you rotate the triangle, the base angles and the vertex angles are going to appear in different positions, okay? Right. So I'm going to give you 20 seconds to take down anything that you need to take down. Like I said, the whole class is being recorded. So even if you miss a few things, do not freak out. You will get back the notes one way or the other. All right. So let's move on to the next slide. Remember the main character in the story, he got sucked into a time warp. Do you all want to take a guess of where he's going to end up? Which time era? Just for fun, just to keep in line with the story. Where do you think? Right? We know he could be in the past. What I want to know is where in the past. And someone just wanted a quick refresher. A straight line is 180 degrees. So let's see where the character ends up today. So he ends up in a place with a whole set of coconut trees. Let's see where that is. Eventually we will know where that is, right? All right, so we're gonna go through some revision again. It have 3 things I want to cover with you all, right? You all will eventually have to draw everything on the screen here, but let me explain it first. I don't like students writing down things that they don't understand. So let me talk first. We are going to talk about parallel lines for a little while. Parallel lines are lines that they go on forever and ever, but they never touch each other, right? They never go towards each other or go away from each other. And the symbol for parallel lines are 2 arrows. That is how you know if 2 lines are parallel. You see these 2 lines I just drew? They will go on forever and never touch each other or move towards each other. everything that I'm about to tell you now only applies to parallel lines, which means if you are going to apply the rules that are in front of you, the examiner has to make it very, very, very clear that the lines involved are parallel. Now, there are two ways the examiner could make you know that the two lines are parallel. He could draw the two lines and put the little arrows in them. Or he could physically write the words parallel. He could say in a sentence form, hey, these two lines are parallel. But I'm hoping that you have a good examiner and he puts what? The two arrows to indicate that they are parallel. So let's move to the first, another thing I need to show you for this explanation. I use the imagination a little bit. You all know how our eye does look, right? Like if I draw a human eye, this here is a human eye and this is the eyelashes, right? Have you all ever seen anyone draw an eye like this? Like they draw a little triangle. How much of you all have seen a diagram like that? Right? If you cannot imagine this as an eye, let me complete the diagram, right? Look at a little smiley face there. That's his chin. That's his ears, and that's his head. All right. So today, when I'm drawing the eye, it's going to be a side view of the eye. And whenever you see a dashed line with an arrow, that's the direction the eye is looking. Right. So that's the concept. That's the concept that I want you to use. All right. Also, I want you to pretend that every line that you see is a wall. So that means if I have an eye on this side, he can look at the wall, but he cannot see on the other side of the wall because most walls, you cannot see through them. So just pretend each line is a wall. So let's start off with alternate angles, better known as Z angles. Whenever you have two parallel lines, right? I'm drawing it big so you can see it, right? If you take any pair of parallel lines, you can slice them. So this pink line is slicing the two blue parallel lines. Let's pretend there's an angle here and there's an angle here. But I want you to use the imagination now. This angle, I want you to pretend it's an eye. Right? So this eye is it's kind of creepy, right? But this eye is looking this way, and this eye is looking the other way. Quick question. Are the two eyes looking in the same direction or opposite directions? Choose one, same direction or opposite direction. That's clearly opposite directions, right? He going so and he looking so. Quick question, can they see each other? Would eye A be able to see eye B? Right? The answer, no. One person said yes. But isn't there a wall in between them? If you were here, even if he strained his eye to look upwards a little bit, the wall would be blocking him. So that there is Z angles, right? In Z angles, the eyes are looking opposite directions. So I'm going to give you a little note here, right? This is for these. You notice in this scenario here, look at this. If I were to draw an eye here and an eye over here, he look in this direction and he look in the opposite direction. And it have two parallel lines. And both eyes cannot see each other because there's what? A wall. In Z angles, these two angles will always be the same. So if here's 30 degrees, over here without any, sorry, pretty small right, and if here's 30 degrees, that means over here is also 30 degrees. If here's 100 degrees without any calculation, this angle is also 100 degrees. So I'm going to give you a note for alternate angles, right? The eyes look in opposite directions and cannot see each other. And you know why they can't see each other? Even the eyes strain and move upwards, so he moves downwards. There's a huge wall in between them. I want you all to draw this, this, and this is, and this, and take down the note as well. And let me know if you are, when you are finished. The nickname for corresponding angles is F angles, right? Even if you don't, you notice you see the letter F here, but that isn't too helpful in my opinion. What it really says is that if you have two parallel lines, and I slice this again, right? If you slice it, right, what I'm going to do is draw two eyes over here, right? Let me draw an eye over here, and let me draw an eye over here. So there's an angle here, and there's an angle here. So I'm going to put in a little eyeballs. All right. This eye is looking this way, and this eye is looking this way. Quickly, are the eyes looking in the same direction or opposite directions? Right, the eyes are looking in the same direction. Do not mix it up with alternating angles. Remember, in alternating angles, the two angles were looking in opposite directions. In this case here, they are looking in the same direction. Will they be able to see each other? Look at it properly. Someone said yes by mistake. That's wrong. How can IA see IB? Look, there's a black line over here. Remember, each line is a wall. This cannot see through the wall. All right? So in corresponding angles, you have to know the situation. You see these two angles, A and B, they will also be equal. So if he is 42 degrees, he will also be 42. Let's go back to these diagrams here. This eye is looking this way, and this eye is looking this way. You notice both eyes looking in the same direction, and one eye cannot see the other eye because there's a wall in between them. Okay? So this is an example of corresponding angles. If here's 82 degrees, over here is 82 without any calculation. Once you spot the pattern, you can reason out that those two angles are equal. These two are also corresponding angles. This eye is looking upwards. This eye is looking upwards. This eye cannot see the other eye because there's a wall in between. Take down this, this, and this, and let me give you a note, right? In corresponding angles, the eyes look in the same direction, but cannot see each other. Right? And someone asks if they need to draw the diagrams. I think I made it pretty clear that you need to draw everything, right? If you're making a note, think about it like this. If you take down everything in class today and you didn't draw a single diagram, when you are revising, you're going to have a very hard time trying to figure out what went on. So that goes without saying. You need to draw the diagrams as well, okay? All right, so let us look at the last one now. Interior angles. Once again, interior angles deal with what? Parallel lines. So I'm going to draw my pair of parallel lines and do what? Right? Put the symbol for it. I'm going to slice them now. Now look at this. Let me draw two eyes now in two particular positions. One eye here and one eye here. Now pretend the eyes can strain a little bit, right? Pretend that they can strain a little bit. This eye is looking this way. This eye is looking this way. Will these two eyes be able to see each other? They will definitely be able to what? See each other, right? Because they're looking at each other. So in this case here, it's possible for the eyes to look at each other. And there's what? No wall in between them. Now there's a little, this one is different. You see how in alternating angles, the two angles are equal? Like this angle and this angle would be equal, or in corresponding angles, these two angles will be equal, or these two angles. Interior angles is a little bit different. These two angles, because they can look at each other, right? One is like almost directly above the other one, right? They are not equal. Instead, they add up to 180 degrees. Let me put it here, right? And I'll give you a little, another note, right? Interior angles add up to 180 degrees, right? They can see each other because pretend this is an eyeball and this is an eyeball. There's nothing physically in between two of them. So they can, and remember the eyes could strain a little bit, like you can move a little bit up, a little bit down. It's a stiff eye, but pretend it can move a little bit. So that means if this angle is 130 degrees, do you think you all can calculate this angle over here? If both angles must add up to 180 degrees. Right, it's going to be what? 50 degrees. Because if both of them add up to 180, and we know this one is 130, you just minus them and you will get what? 50. So let me put a little note for you here. All right, okay. The eyes can see each other, right? But of course, this only applies to parallel lines, right? Oh, sorry about that. Oops, right. Let me know when you're finished, and after you note it. Interior angles, it is usually see the letter C. You're seeing the letter C there, right? And this one here is a kind of backward C. Right? It's like they made a C with what? Straight lines. Let me know when you're finished, please. Let's continue the storyline and see where we are at, right? So it seems that he was teleported into the well, let's read here. He went back to 65 million BC, somewhere in his South American continent, right? All right, so here we have some practice questions. Do not draw all at the same time, right? Let's just do one at a time. So I want everyone to quickly draw A and B and work out the values of X, right? Draw it first. Don't send the answers on the chapters yet. Draw A and B, and we're going to try to reason out the values of X. Only A and B. So before I give away the answer for part A, right? If this is an I, look at this. You have the 125 and the X. So this I is looking this way, and this I is looking this way. Are both of them looking the same direction, or are they looking the opposite direction? What does that look like? That looks like the same direction, right? Both of them looking kind of upwards. Can they see each other? Can the 125 and X see each other? The answer is definitely no, because there's a wall in between them. Which rule is that? Alternate, corresponding, or interior? That's, look at your notes, right? That's definitely corresponding angles. And corresponding angles are always equal. So if he's 125, well, then angle X is also 125. All right? So that's the answer for part A. For part B, this eye is looking this way, and this eye is looking the other way. So look at the arrows. Well, both angles are looking in the opposite direction, and they cannot see each other because of the wall. So to me, these are alternating angles. And alternating angles, if you look at your notes, the values are always the same. So if here is 57, then, well, I can't write it inside here, but I'll just put the 57 degrees here. Both 57 and X are equal because of alternating angles theory. Now, usually you have to read the instructions in the exam, right? Sometimes the examiner will say, just put the answer. And then sometimes the examiner will say, explain your answer. If he asks you to explain the answer, you have to let him know that, A, this is a situation involving alternating angles, right? Different teachers have different rules. C, draw C and send your answer afterwards on the chat. Do two things, C, D, and E. Do those three, C, D, and E. Draw and send your answers. Right? The easiest way to work out part C is actually not alternating angles, not corresponding angles, not interior angles. Close to the beginning of class, remember we did something called X vertically opposite angles? And I told you vertically opposite is when you see an X. And I told you the angles on opposite sides are always equal in an X scenario. Do you all see an X here? Look at it. This line and this line. Is that X clear? I'll draw it back here, here, and here. Right. Look at the 70 and the X. The 70 is here and the X is on the other side. These two angles are on opposite sides of the X. So that means X is also 70 degrees. So this is a case of vertically opposite. All right, that's it. Have more than one ways to get it out, but to me, let's just stick with this one method. I know some of you all are suggesting much different methods, right? But now start the class, right? And some people are a little shaky on the theory still, so I don't want to overload anyone with different methods. Let's just stick with the easiest method for the time being, right? Vertically upward. Make sure and write the reason for it also. All right. So D, who can tell me what theory they used for D? Was it alternating angles, vertically opposite, corresponding, or interior angles? Which one was it for part D? To me, that looks like interior angles, because if this is an eye, he is looking this way and he is looking this way. Both of them can see each other. It's parallel lines, and there's no wall in between them. So the two eyes could see each other. And remember, we said corresponding angles add up to how much? 180. So that means if here is 105, we just minus it from 180, and we'll get how much? 75 degrees. So X is 75 degrees. And you can add them back up after. 105 plus 75 is 180. Right? E. Let me see what you get for E here. I'm pausing it here. So you need to think on E. E is not a straightforward question. Correcting me. This one here is not corresponding angles. I made a mistake. This is interior, a saying interior and a right out corresponding. My apologies. Let's clear the screen, right? So we want to find X. Fair enough. Now, do you all see a kind of Z angle here? Look at this. This, if I put a pink angle here, right? Let me clear it up here. If I slice here, do you all see, sorry, the line going the other way, my mistake. If I draw it like this, you all see a Z, zip, zip, zip. So that means this angle and this angle is supposed to be the same. So if here is 53, then by alternating angle theory, over here is also 53. But look at the pink angle. X is below that. You don't want this pink angle. You want X. But look at this. Didn't we say at the beginning of class, a straight line, any straight line in the world, the total angle is how much? 180 degrees. Do you all remember that from the beginning of class? That a straight line is 180. So that means if I have a straight line, and this is a straight line, right? Look at it from A to H. That means this entire angle here is supposed to be 180. So if here's 53, then this angle is how much? 180 minus 53, which I think is how much? 127 degrees. That's one way of getting it out. That's only one way. Take down that way, that a straight line is 180 degrees, like you recognize that fact. And because of alternating angles, let me put a little rule here. How did we get the 53 here? Because of alternating angles. And then we minus it from 180, because a straight line is 180. Right, so let me give you a few seconds to take that up, right? 20 seconds. Wait. We're going to get the same answer if we use a different method. I want you all to look at this pink angle here now, right? This 53 and this angle here, the new pink angle, what situation is that? Both eyes can see each other. What situation is that? Is it alternating, corresponding, or interior? That seems to be interior angles, right? So remember, interior angles add up to how much? 180. So if here's 53, how do we get this angle? We minus the 53, and that gives us 127 degrees. So this pink angle by interior angle theory is 127. But they didn't ask us for the pink angle, they asked us for X. You all see the letter X here? I'm talking about the situation X, number vertically opposite. Remember, angles on opposite sides of the X are equal. So this is a little X here. If here is 127, then the angle on the other side is 127 degrees. Either way, we come up with 127 degrees. Okay? All right. F. Draw and send the answer for F. 1 second, guys. All right, I have to think it through as well. First of all, are these two angles corresponding angles? Are they corresponding angles? Look at them carefully. He is looking this way, but he is looking this way. For them to be corresponding angles, they have to be looking the same direction. They are clearly not looking the same direction. But if I draw a pink angle here, look at it. This eye and this eye are looking in the same direction, and they cannot see each other, which means this angle and this angle are equal. So all we need to do is figure out the value of this angle, and whatever we get for him, X will have the same exact value. Which brings us back to straight lines. The angle across a straight line is 180 degrees. You all see a straight line here. If here's 133, how much again do we need to make the 180? Take 180 and minus the 133. I need my calculator for that. You're going to get 47 degrees. And you could add it back up. 47 plus 133 is 180. And we now said the pink angle and X are corresponding angles. So if here is 47, then Mr. X is also 47. Right? It have more than one ways to do this question, but I'm going to stick with this one method, right? To prevent any minor confusions in class. Sanchez does. Oh, he runs, and unfortunately, he runs into bigger problems. Right? Which is a lesson in life. Never run away from your problems. Always stay and face it. All right, so let's see. This is a saying, from the frying pan into the fire. That's a saying, meaning that sometimes you have a big problem and you try to avoid the problem, but you instead end up with a bigger problem. It's a common saying. All right. Oh, here's where things get a little bit more complex. I want everyone to try only do A. And your job is to find X. Now, in these questions, there are a lot of distractions. Sometimes the examiner will put things that you don't need to get out the question to distract you. Draw and send the answer for X in part A only. All right, now there's a distraction in this question. A lot of people are saying the answer is 66 because they're seeing a 66 here. So they're thinking the answer is either 66 or 59. So you're kind of doing a little guess. But you all remember this thing called alternating angles, where you have two parallel lines. And when you slice the two parallel lines, right, you get a kind of Z shape. Remember, this angle and this angle would be the same. because this eye is looking this way and this eye is looking the opposite way, and they cannot see each other. Do you all see that situation here? X and 59 are alternating angles. He's looking this way and he's looking the opposite way, and they cannot see each other. So X was just simply 59 degrees. Some of you all were overthinking it. And you see, and this is exactly what the examiner plans, right? Distractions, right? But you have to be able to look beyond those distractions. That 66 has nothing to do with the question. Nothing, right? But just my own personal question. How much would this angle be? The blue angle here with the dots. Just asking, how much would that angle be? Right, that angle would be 66 degrees. The reason is vertically opposite angles. Whenever you have the letter X, like an X situation, opposite angles are always equal about the X. So if here's 66, the opposite side of the X is also 66, right? That's just my made up question on the spot there. I want you all to draw B and find angle X for me in part B. I need to think it through too. What I did to make it easier, since you all are accustomed with the horizontal, with the parallel lines going horizontal, I tipped over the shape this way. I rotated the shape in a clockwise direction. If I do that, K to A, look at here, K to A becomes horizontal, L to B becomes what? Horizontal. Now, if this was an exam, right, you would have a sheet of paper, right? So you could have just turned the sheet of paper to make it easier to understand. Do you all understand the top diagram and the underneath diagram? Do you think you can imagine turning it 90 degrees? Which means that this angle here is 55 degrees, all right? And they're asking you to find this angle here. This is angle X. So what I did was I kind of redrew the diagram. I honestly think the 72 degrees has nothing to do with that question. It's just there to what? Distract you. So try your best now to find what? X. Now here's the thing, right? Here's how I would find X now. The thing about it, if there are two ways here, there are two ways to do this question. I think the easiest way, there are actually about 3 different ways to do this question. Give me 1 second. I think I just need to draw. We got a different color here. The green angle. Let's concentrate on finding the green angle. The 55 and the green angle. What situation is that? Is that alternating, corresponding, or interior? I think that's interior because the two of them can see each other, right? And it have 2 parallel lines. And interior angles always add up to how much? 180. So you think you all could find this angle for me, the green one? You have to take 180 and minus what? 55 degrees. Right? I think we're going to get how much? 125 degrees. So this drawing in here, that's this angle over here. You notice these 2 of them are the same thing on my diagram. So these are the 2 interior angles. So here's how much? 125 degrees. Here's 125 degrees. So I'm updating both diagrams. Do you all see an X here? Look at it. X. An X. Isn't this vertically opposite angles? In vertically opposite angles, the angles are always equal. So if here's 125, then over here is 125. So that's the final value for x. 125. Right, so it's two steps. You have to use interior angle theory first, and then you can do what? Vertically opposite. Now, like I said, there are more than one ways we could have gotten the final answer of 125, but due to the complexity of the question, let's just stick with one method for the time being. Part C. So let's see how the examiner tried to trick you in this question. Let me redraw this diagram, but a little bit neater. I am going to draw back this diagram, but ignore this line. So I'm only going to draw this. All right? I'm only drawing this line. Remember, they want us to find this angle here, x. Here's x. Who can tell me what's the value of this angle here? This dashed line. How much is that angle? Isn't that angle 101? Because if here is 41, and well, here is 60. To get the total angle, we just have to simply add it. And that's all we had to do to get that particular part of the question. 101. Now look at this, guys. It's two parallel lines. There's a line slicing here. He's looking downwards, he's looking upwards. Can these two eyes see each other? What does that look like? Can those two eyes see each other? Yes. So what situation is that? Is that alternating, corresponding, or interior? That's interior angles. And interior angles always add up to how much? 180. So if he is 101, to get the balance, you just minus 101, which is 79. That's the final answer, 79 degrees. You see this line here? It was a distraction. That was a distraction. You had to kind of like eliminate that line and then proceed with the question. All right. All right, take down what you need to take down, and we need to discuss it. So let's talk a little bit about the homework, and then I'm going to write down what the homework is also after I'm finished talking about it. So when you go to the school website, the iLoveLessons.com, right? This is the school website that you are going to see. Today's class is going to be uploaded to summer recorded classes. That's the most obvious place to put it. So when you click on summer recorded classes, scroll down, this is all the classes for the entire summer program. Somewhere here, you're going to see Saturday maths. That's obviously today's maths class, right? Today is Saturday. The link is going to be placed over here. It's not there right now because I haven't uploaded it as yet, but by tomorrow, it will be there. That's the first thing, to review the video. Make sure everything is solidified. Next on the list, everybody here needs to be very, very strong in algebra. It doesn't matter which topic you are doing in maths. If you're not good in algebra, you're going to fail maths. That's a given. For homework, you are going to go to the maths classroom. It's up here, clearly labeled in the menu. Click on the maths classroom, right? Click on the maths classroom. And when you do that, scroll down and you will see lesson 1. Click on lesson 1. You're going to see a whole set of videos. Don't get frightened. You're not doing all. You're only doing from video 1 to 7. Make a note, you're doing from video 1 to 7. Some of these videos, like video 2 has a worksheet, and video 4 has a worksheet, and video 7 has a worksheet. Make sure and do the worksheets. All my worksheets come with answers. You just need to work towards the answers. You don't have to submit anything to me. So it makes no sense just cheating and putting down the correct answer. Like I said, you're not doing it for me. If you cannot get out a question, take a break, come back and work it out till you get the answer. You're doing this for you, like I said, not for anybody else. Everything I just said, I just wrote it on this slide here. Make sure and screenshot it, and I will discuss 3 in a little while, right? Screenshot it so you don't forget what the homework is. Have it prepared for next week. Once you understand what the homework is, you're free to leave, but I need all the adults to stay back after. The adults will have extra homework because you all are trying to do the exam in 1 year. So everyone is free to leave except the adults, right? Screenshot it. And oh guys, and if you all know one small thing, guys, if you all know anyone who is interested in classes, just tell them WhatsApp me and say Saturday maths. That's all they need to say, and they will get the spot. All right. You have the same homework that I just discussed, except for number 3. Anything, remember on Monday, there's a maths class. Now the maths class is doing different topics to the Saturday class. I'm not asking you to attend the Monday class, right? The Monday class is filled, but you do need to follow up with every single thing that's going up in the Monday class. And you can find the full recordings for the Monday class on the school website. When you go to the summer recorded classes, which is where all the classes are recorded, you will see the first thing is Monday math. And the first Monday math class passed Monday 1. So I needed to look at that video. The reason is, if you decide to stay with the school in September, you all will be merging with the Monday class. So I need you to keep up to date on what's going on in that class. But the reason you're in the Saturday class is because a lot of you all have been out of school for a while. So you'll need to stick with the Saturday class temporary until you get your footing straight, like you get back on track, you shake off the rust, right? But please do not let everything in Monday pile up on you. Start up on it today or tomorrow. It's a lot of work. Everyone agrees? Well, understands? Right? Right. I will send back the website in a little while, right? Okay, guys, so once you understand, you're free to leave, okay? Right? And if you know anyone who is interested in joining the Saturday class, just tell them WhatsApp me and just say Saturday maths, right? That's all they have to do, Saturday maths. Okay, I know some of you all have, okay, I'm gonna say this back, all right? All right,